Today we are going to build a stack in Swift. In the previous episode we talked about arrays, and the next obvious step is to talk about stacks. Now, stacks are not part of the Swift standard library, so we need to build them out. If you want one-on-one tutoring, go ahead and check out rebeloper.com. So let's just open up Xcode, and we just have here a plain old playground. It says hello stack. That's fine. What I'm going to do is basically build a stack. Now, what is a stack? Think of it like a stack of books. Just put one book and then another on top of it, and on top of it, and on top of it, a new one. And if you want to remove one, you're not going to take the bottom one or anything in the middle. You're just going to take the one from the top, and so on. So again, top, top, top. So think of it something like this. So you just have one book over here, and then just put another here, and another here, and then another here. And if you want to remove it, just go just like this, remove on top. Now, this is quite important. This is viewed, you could be viewing this as a limitation, but it's a hard limitation that has very much really great advantages. So, and we're going to cover them later on when we are going to get to the algorithms part. We're going to solve those algorithms. Make sure to check out the link in the description for the whole playlist. And also, if you like this video, give it a thumbs up and subscribe. Now, we're going to build this out from scratch because it's not part of the standard Swift library. So yeah, let's just build it out. I'm going to make it public, just public. So maybe if you want to use it inside a Swift package, you can do so. By the way, I also have a Swift package for these structures, data structures on my GitHub repo. Anyways, so let's create a struct, and that will be a stack, and this will have elements. So we're going to pass along elements right over here. Now, what is actually a stack? Well, it's basically an array of these elements, but it's a glorified array. So it has limitation. It has only few options. Therefore, this array needs to be private. So private var storage, and we have an array of elements. Initially, we have it as an empty array. So now we could just go ahead and create our stack, or rather let it be a variable. So, we want to mutate it. Variable stack equals stack. I don't know, auto-completion is not working right over here. We just need to give it its initial type of elements, because we just added element right over here. And yeah, basically that's it. Now we have our stack, but of course this the storage is private, so we cannot access it, but we might want to access it. One way of doing that is through its initializer. And by the way, let's just make our not built-in struct initializer also public, so we can have this inside a Swift package, because otherwise the internal default built-in initializer for the structs are not actually public. They are internal, of course. Therefore, you will not be able to use them inside a Swift package. So to fix that is to make the init public. There we go. Just simple public initializer. Now, you might see that it pops up the suggested initializer. So I will do that again. Init, public. Let's just go and start with public init, and it did not pop it up, but I will just write it out for you. Elements of type array of element, and let's just say storage equals elements. There we go. So with this, we are going to be able to initialize our stack with a predefined set of elements, just like this. So let's just say 1, 2, and 3. Great. Now, if we are going to do this, then we could just simply remove the type setting up the time because it infers it. And also, really nice to have is to have it as an array literal. So I'm just going to create an extension right over here, extension on the stack of expressible by array literal. There we go. And we actually need to have the init array literal, and these would be not array literal elements, but array literal, just an element, and storage equals elements, the same thing that we had right over here. So those are the initializers. Let's just have a little bit more room right over here. Those are just the initializers. Now we can add in the functionality. Now, what is the functionality? It is limited by design. You either push or pop. So pushing means putting one new element on the stack, on top of the stack, and then popping, taking off that one element, not taking it from anywhere else, only from the top. So let's just write it out. Public. It's going to mutate our storage variable. So mutating func, and then push an element. There we go, element. And because this is an array, basically we are just going to say storage, not string, but storage dot append that element. So we are just appending on top of it. So as you can see here, we have our storage 1, 2, 3, and we are just going to say stack dot push, I don't know, 4. And we will see it right over here in just a sec. There we go. We just pushed our 4th element, and here it is. But this doesn't look really nice. It's counterintuitive. We might presume that 1 is the top because, in arrays, we're just counting from 0, 1, 2, 3, the indices, and we are appending. So the top is basically the end of the array. We want a little bit more, readable debug descriptions. So that's what I'm going to do next. I'm just going to create an extension on the stack again for custom string convertible and custom debug string convertible. Now, what's the difference between those two? The custom string convertible works for user-friendly, for us developers. When we are using print, that's what the custom string convertible will be added out. And for custom debug string convertible, it's for debugging, for debug print, for example. Now, we need to add in 2 properties right over here, one for each. And the first one is the description. And actually, I'm just going to copy out all of this so we don't waste time on typing this out because it's redundant. It's the same thing. What we have here is separate lines. I have the top over here. I'm mapping the storage, the array, reversing it, the issue that we had, and we are joining by the separator of /n, which is a new line. Okay, the same goes for our debug description. There we go. Let's just add it in there. Okay. So now we should be able to see new things. I know this is kind of strange, but if you are adding a print statement, let's just have a print statement right over here after the stack. So print and then the stack. And we should be able to see it right over here. Let's just build it. Well, we don't even have to, here it is. 1, 2, 3, 4. So the 4 that we pushed on top of the stack is on top right over here, which makes sense. We are inside a stack. And actually, now I believe we can just get rid of the results pane over here. I know it's going to complain, but it's much easier to just see the console right over here at the bottom. Okay, so that's how we push, and we're just printing out the stack at this moment. How do we remove the topmost element? Well, that's what we are calling pop. So let's just have it right over here. Public, the declaration, public. It's also going to be mutating func and just pop. We don't have to specify what to pop because it's just going to pop the topmost element. And maybe we want to know what that element. Now, this could be optional because we might not have anything. It could be nil, sorry. Might not have anything to pop, therefore this return statement needs to be optional. And also, we might not be interested in what element has been popped at that moment. So we are going to mark this as discardable result. Okay, so how do we do that? Again, it's quite simple because we have all of these functions for the arrays. Storage dot remove last. So there we go. We are going to remove last. Now you might be tempted to write out pop k number of elements. That's not how stack works. You shouldn't be able to pop out k number of elements. You should just pop only the top. So pushing and popping. So let's see that in action. Let's just have stack and then just pop. And let's see that. Let's see, there we go. Oh, we're not printing it out. Okay, so let's duplicate this and bring it all the way down. And now it's building again. Now we can see that we have 4, 3, 2, 1. And by the way, the initial one is 1, 2, 3, and then 3, 2, 1. As you can see, we popped the topmost element, which is actually what we wanted to do. Now, this is the basics. This is the minimum that you want to have. Now, I'm calling it minimum because there are a few things that you might want to add, a few improvements of life things. And the first one would be to just check if the stack is empty. So I'm just going to add in here another public variable. So a new public variable, public var is empty. There we go. This will be of type Boolean, of course. And we're just going to basically check if our storage is empty. You know, in many cases, you do want to check these out. There we go. I'm just going to comment out these lines so it's not going to build all the time. I'm not going to test all of these if it's empty or not. You go ahead and do it on your own. Now another one is the count. In many cases you want to know the count. So that's also a public variable count int. And then we are just going to give us back our storage dot count. Okay, so those are the two variables that are really, really useful. One other thing to do is to just take a look at the topmost element, right? So we are calling it as peak. Now this is again optional, but it's highly, I highly recommend it. So another public func. This time around, it's not mutating because, we are not mutating the storage at all. And it's called peak. And it's going to give us back the element if it's available. Again, if this is an empty stack, then it's just it should return nil. And basically, we are just going to grab the last element from the storage, so last. And as you can see, last is also optional on the array. Okay, so this is how we peak. We take a look at the topmost element. Now, we could also clear our stack. So let's just do that. A public, this one will be mutating because, we are accessing our storage. We are manipulating it. So let's just close this clear. And so that would be storage dot remove all. There we go. And finally, this is kind of not very used, but maybe you want to actually access or convert rather your stack into an array. So that's what I'm going to add over here. Public func to array. And that will be an array of elements. And then that's basically the storage. So we are providing the the private storage right over here.